All right, everybody, we're now going to move on to the interferometer. So you come over to this INTF tab. I already went ahead and did this. You load the interferometer data, the same one from that you load on the home screen. It is not pre-calibrated because we're dealing with the the raw data. The header line, don't worry about. This is if you're running into trouble and for some reason the format is different than it was in 2025, you can go and adjust what the backend's actually reading. So for some reason there was 61 lines in the raw data file before the actual time series data starts. You can go in here and change it. But the other things that you need to do, event timing, just the hour, minute, and second, that's easy, and then the T0 time as well. This button should automatically sync it from this home tab if you have it in there, but if not, you can just go over and copy and paste it. On default, you might have a cosine shift calibration. I set these to 0. I'm going to go into a bit more detail about what that does in a second. But yeah, for now, I'm just going to change my azimuth from 00 to 0360 and hit update plot. And we should get a full picture of all of our raw data. Yeah, and here it is. So I can even click this and let's just zoom in on this area. So this is pretty cool. It's basically a map of the entire lightning flash, and while it might seem like oh wow, we have all this information, which we do for the actual event that we're interested in, when you actually chop it down to where our event is. Let me do 329, not 328, and then I'll just go 324000. Update plot. It shrinks significantly, and that's not a mistake. That's all that there is for this event. This event's already been analyzed. So here, let me lock this in place, 250 to 260, and we're going to go like 0 to 20. So as I said before, this is very similar to what we're seeing on the home tab, right? Like this shape here, how it propagates around 15 to 10 degrees from the interferometer. And when you're looking at the elevation degree, you can just think about it as the literal angle from where the instrument is reading the points to the ground, right? And this is that angle. So what we want to eventually do is extract the true height of these points, but we have to start by calibrating it correctly. Now there's a whole method of calibration that I had to figure out. Now if you're watching this in 2026, Wayne, you'll probably get this data from Mark Stanley. If he gives you a cosine shift A and a cosine shift B, you put these in here and use those. If not, what you're going to do is you're going to run that auto calibration, which you're going to input your LMA file. So let's go ahead and do that. LMA. And getting this, there's something else on the wiki about it. So we're just going to go run LMA calibration. And just like that, it finds the cosine A, cosine B, and it automatically shifts the data, which is awesome. So let's go ahead and change this from 0 to 10, and we're going to hit update plot, and maybe change the time series a little bit so it looks a little bit nicer. Just the colors, something more like this, a little bit closer to what we'd actually want to see, or what we do see. And yeah, that's basically how you calibrate the interferometer. Super easy. And just the last thing we need to do, well, first of all, I'm going to go file save. And then next thing I'm going to do is export calibrated data. Now this is important for the home plotter, the time shift, and a few other plots that we're going to make later. So I'm just going to go ahead and export calibrated data. I'm just call it INTF calibrated tutorial, my tutorial data folder, and it's there. So if we actually come back here to now the home tab, and we change this interferometer data file, open, then you hit INTF is pre-calibrated, load all data, because now we've calibrated it, pre-calibrated, that's what that means. Look, now we get something that's much more something that you'd expect, right? I mean, it clearly starts at some level of the cloud base and propagates down towards the ground. So what I'm actually going to do with this is change this from 10 to 20 and hit update plot. And there you go, maybe even 12 so it doesn't interact as much with the fast antenna and something like that. Yeah,